This is for Lab 5, the Choose Your Own Adventure, the Slinky Drop. The purpose of this experiment is to learn the relationships between gravity and springs or objects with tension, and if that object is the only object in the system, then and it's in free fall, it's moving on its own as the only thing in the system. The models and fundamental principles needed for this are Newton's second law, force equals mass times acceleration, and gravity and tension. The results of the lab will show the tension of something falling will cause the top to fall until the object is back at its equilibrium position, and then the whole object will fall together. The experiment information is the system is the Slinky and the Earth. The initial conditions would be the position of velocity of and the velocity of the bottom of the Slinky. And the experiment is basically just having a fully stretched out Slinky hanging, and then you let go of the top, and you'll notice that the bottom stays exactly in the same spot until the top reaches it, and then it all falls down to the ground together. The data clearly shows this, as you can see that the distance does not change for the first while when you compare the distance versus time, and then it begins to change, and the little change at the beginning is due to tracker errors. And then this is the code. The top one is the first while loop for the just flat area, where the force of gravity and the force of tension cancel out, and so the total force on the ball is 0, so the velocity is constant and the velocity starts at 0, so it's all 0 for the bottom of the spring. And then the second while loop is once the top of the spring meets the bottom of the spring, then the force of gravity is the same. Then there's the force of drag, which is just about negligible. So I made it negligible because I put the formula in, but the force is so small, and I don't know the exact size of the Slinky. And then I calculated the velocity with acceleration times time to get the new velocity. And then the results of the code gave me these two graphs, which were pretty accurate with the tracker data. The data is also skewed because there's more points at the end, so it changes it a little bit, but the final position is 0.1 off of the actual final position, which I'll get to why in a little bit in the errors, and I do know why 0.1 off, and then there's a little bit more discrepancy, which are other errors that I do not know. And the final velocity seems pretty accurate for what it should be. Yeah, they're a little below as well because of the same reason, but yeah. So the possible errors, as I said earlier, was that just tracking could be off in general, and then formulaic and rounding errors in calculating, and then this line, the ball dot velocity equals ball dot velocity plus 0.0924. When it worked, I tried to insert it in between the while loops by breaking the first while loop, but I wasn't sure how to because it kept erroring. But I calculated it out, and the 0.0924 should have been how much velocity the bottom of the spring immediately started at, because it took the top's velocity with it, because the whole thing's moving and then it hits it and it just immediately starts going down. This means that an object in free fall can be still, or a part of the object can be still in the system if a force from itself, even the tension force, holds part of it up. And it supported the purpose because it showed us how and why the Slinky would fall.